testing. As I said, you know, we'll have a look at in a little bit more detail. So RCD testing, once this wakes up, is testing the functionality of the RCD. So we want to make sure that the RCD works. Now, what does that mean? What does RCD working mean? Well, the whole thing with the RCD is if it detects, you know, some current flowing through it, it has to be the right amount of current, and it has to operate at the right time. So these are the things we're going to look at here. So RCD and functional testing. So the operation of an RCD. The object of the test is to verify the effectiveness of the residual current device. That is, it's operating within the correct sensitivity and proving the integrity of the electrical and mechanical elements. Now, on a previous lesson, we've looked inside an RCD, and we've seen that there is quite a few mechanical operations and electrical elements inside it. So this is a tester that we could use, which is just an RCD tester. We're going to look in the video in a minute at some other testers. This is the one that I borrowed from the college, just to have a look. So this has got the RCD testing down here, and I'll add some more details onto that, and we'll go through the things. So you've got the different milliamps of the RCD, depending on what type of RCD you're going to use, and then we've got the different tests, and we'll have a look at that in a little bit more detail in a second. So operating times. So what you've got here, this is from the regs, is the different types of RCDs. So the common one that we use, which is a BS61008. Now, the operating time, maximum operating time at 100% rated tripping current. So the tripping current is what the RCD is rated at. So it could be 10 milliamps, it could be 30 milliamps, it could be 100 milliamps, depending on the RCD. So what 100% means is that when it hits whatever figure we're looking at, and we'll look at that in a video in a minute, but say it was 30 milliamps. So when it gets to 30 milliamps, it must operate, and it must operate in this case here, 300 milliseconds. Okay, so it must operate in 300 milliseconds. And if it was an RCBO, it's exactly the same. And then we have, now we do get them with a time delay, and we looked at that before. So we were looking at them for, if we were looking at ones with a slight time delay we were adding, obviously we would have a different details. But if it was at normal, non-time delayed, this is the figures. This is where you would look to get those figures. Additional protection. So where an RCD with a rated residual current of IN, so that I delta N is its operating, so 30 milliamps, 100 milliamps, 80 milliamps, not exceeding 30 milliamps, is used to provide additional protection in the event of a failure of basic protection or the provision for fault protection or carelessness of users. The operation of this device must not exceed 40 milliseconds when subjected to test currents of 5 times. So what that means is, and we'll go through this in a second, so we'll go through 3 tests in a minute. One is at half, one is at 1 times its operating current, and one is 5 times its operating current. So what they're saying here is the maximum test time should not exceed 40 milliseconds when we use it for additional protection. So if we're using it for additional protection, 40 milliseconds. So it has to operate at that time, unless the protective conductor potential rises by less than 50 volts. So saying if it rises less than 50 volts, then don't worry about it. The instrument supplier will be advised on that. But if you had a question, it's on 40 milliseconds for additional protection. Now, when we do our tests, at 0 and 180 on the sine wave. So I've added this picture of a sine wave just to show you. So what we do is we do our test here when it's about to rise. Yeah, so we do it when it's rising at 0, And then 180 is here, the falling slope. So we do two tests. We do it at 0 and 180. So we make sure that when it's rising, it works, and when it's falling, it works, because we just want to make sure that in all of the parts of the sine wave it works. And we will do those tests at half, at 1 times the rated current, and at 5 times the rated current. So when we test an RCD, we do 6 tests. We do 1, 2 at half, 1, 2 at 1, 1, 2 at 5, and then we do a 7th test. And then the 7th test is actually physically testing the button. So this is the functional test. And an integrated test device is incorporated into each RCD. This device enables the electrical mechanical parts of the RCT to be verified by pressing the T or test button. Operation of the integral device does not provide means of checking. So what this doesn't do, it doesn't check the continuity of the earthing conductors or associated CPCs. It doesn't check an earth electrode or means of earthing, or any other parts associated with the installation, or the sensitivity of the device. The test button will operate the RCD if the device is energized. So all that's doing is, and we've seen it on the diagrams, and I should add a diagram next time onto here, it's just making sure that the RCD works. Now, this is an old slide, and it says confirm the notice of the RCD to test the RCD quarterly. It must be fixed in a prominent position. So what it's saying is near the RCD, you should have a notice. Now, that's changed in the latest regulation. So the next slide, this is 5.14.12.2. So this is from the regs, and now it says this installation or part of it is protected by a device which automatically switches off the supply if an earth fault develops. Test 6 monthly by pressing the button marked T or test. The device should be switched off the supply and then should be switched on to restore the supply. If the device does not switch off the supply when the button is pressed, seek expert advice. Now, this should be fixed prominently near the RCD. So it has changed to 6 months. I'm just going to go through this little video which I've got ready here. And this is just a small short video which was all prepared. It's only 3 minutes long, so I'm just going to show you this. I might pause it just to show you. So it's a mega.
So let's look at the RCD test functions. You can see you can select straightforward times half, times 1 and times 5 trip currents, and by pressing the function key on the front, you can select whether or not you're going to test at 0 or 180 degrees, so either the rising or falling side of the waveform. Pressing and holding the function key will allow you to cycle through the different types of RCD, type A, type AC, or selective, or a variance of any of these. Finally, a B-type breaker can be selected. Here we also have the auto test facility, where you can dial up the rated value of the RCD, start the auto test, and the unit will run through the whole sequence. And then,
so I'm just going to pause it there. So a lot of the time they use the auto test, but as I've said to you previously, when we go through the testing and when we do the testing, we will do each test, or we'll go through every test. So we'll set it to half and we do our 2 tests. We set it to 1, we do our 2 tests, and we set it to 5 and we go through our 2 tests, because we're going to learn how to do it when we're out in the real world. And I've always gone back to the driving test analogy. You know, auto actually helps me there. We're going to learn how to do it manually, but then we can always drive an auto.
We have the ramp test. This is particularly useful when fault finding, because it will prove at exactly what leakage current an RCD will operate or trip. There is also a variable RCD test, which we will look at later. So let's look at the auto test sequence for a 30 milliamp RCD. Pressing the test button, the first test makes sure the RCD doesn't operate with the times half test or half the tripping current. Next, it completes a times 1 test at 0 degrees. We reset the RCD and it will repeat the times 1 test at 180 degrees. Reset again and it ups to 5 times the rated tripping current at 0 and finally 5 times at 180.
I'm just going to pause that for a second. So when we're going through these tests, the first thing that we need to look at is what he's done here, and I haven't got the test in front of me. So when we do the auto test, we do it at half, and the reading that he got there when he did it at half was over 2 seconds. You don't want it to trip, so you're almost testing for nuisance tripping. You don't want the tester to trip when you're doing it at half. You're checking to make sure it doesn't trip. You're checking that, in this case, we've got 30 milliamps here. We're sending 15 milliamps through, which we know shouldn't trip our things. So we do our test that way. And then we do our test at 1, and we do it at 0 and 180, which he's doing on the auto. So then we'll see it, and then we'll do it at 5.
0 degrees. We reset the RCD, and it will repeat the times 1 test at 180 degrees. Reset again and it ups to 5 times the rated tripping current at 0 and finally 5 times at 180. You'll see the display shows end, and then using the function key you can cycle back through and look at the results. The no trip half test, the times 1 at 0 and 180, and then the times 5 at 0 and 180. With the ramp test, again with a standard 30 milliamp RCD, when you initiate the test, the current is ramped up slowly, indicating exactly at what value the RCD operates. You can see here that the RCD tripped at 23 milliamps. The variable RCD test allows you to dial up a non-standard or programmable RCD test current. For example, to test an 80 milliamp RCD, you press the function button to activate the selectable RCD feature, and by pressing the up and down arrows, you can adjust the value to match the RCD to be tested. Press the test button and do a times 1 test, and you can see here the reading is 40.6 milliseconds.
So I'm just going to come out of here quickly. I'm just going to get back to the group meeting. I'm just going to stop the recording scenario.